Jai Hind everyone. I am Deepak Narang, Assistant Professor in Electrical and Electronics Department of Ajay Kumar Garg Engineering College. The topic which I am going to talk about sensor, its classification and factor which affects the which influence the basically choice of sensor. Okay, as we know, in this growing era of automation, we are surrounded by many sensors. If we talk about our washing machine, oven, refrigerator, or mobile phone, every appliance is equipped with numerous sensor. So what is sensor and how they can be classified? So in this lecture, we are going to talk about all these things. So these are basic contents of our today's talk: measurement system, elements of any measurement system, what is sensor or transducer, classification, its characteristics, and factor influencing the choice of a sensor or transducer. Okay, so first of all, what is measurement? How we'll define what exactly measurement is? Measurement is exactly a process of gathering information. For example, some process is going on, like we are cooking our food. So what could be the possible parameters which can be helpful in cooking food so that a better taste can be obtained? So like what should be the temperature or pressure in the cooker. So these are various readings which we must know: quantity of water, salt, and other spices. Okay, so if we gather all this information in some numerical form, it becomes measurement. So measurement is a process of gathering information from physical world and comparing that information with the agreed standard. Okay, so measurement is generally carried out by some using instrument which are designed and manufactured to fulfill specific tasks. Like our simple scale is a sort of instrument which is used to measure the length, and sensors are basically the primary elements in that instrument to respond the physical world, or all the quantities which we want to measure are existing in physical nature. Okay, they are in analog in nature. We want this physical quantity in readable form or in some numerical form. So how can we do this? We generally do it by using sensors. Okay, so sensor is prime front end of any type of instrument, like our thermometer, which is used to measure the temperature. Okay, so it becomes a sensor. Okay, and if we talk about the ATM machine, so card reader, which is actually reading the barcode of that ATM, is the first end of our that particular process. So sensor is basically a primary element of any instrument. So in this we are going to discuss the elements of measurement system. So first element, as we discussed above, is primary sensing element. So this is that part which is actually responsible for this conversion, the quantity which we want to measure, and that quantity gets converted into another form. It may be electrical or some sort of other mechanical form. Second is variable conversion form, which is followed by variable manipulation element, then data transmission, and then a sort of storage or backup, and last is data presentation element, where data is displayed for human being to observe. So one by one, let us talk about all these elements. First of all, primary sensing element. In this block, basically the primary element is always a sensor, which convert that quantity which we actually want to measure into some electrical form, and the measure is then immediately converted into analogous electrical signal which is done by transducer. Okay, for example, are thermocouple. This is sort of sensor, or we can say transducer, which actually convert temperature into electrical signal. Then second is variable conversion element, which are needed where the output variable of primary transducer is in inconvenient form and has to be converted into more convenient form. Actually, what happens sometimes, like if we want to measure pressure, okay, but the sensor is of sort of which is actually which can measure only displacement. We are using the sensor which is which can measure only displacement, but our quantity of interest is pressure. So in this case, we can use such structure like Bourdon tube, which convert that pressure into displacement and make this conversion convenient for succeeding stages. So this is the job of this variable conversion element. It converts the form of one quantity into another, like here pressure is being converted into displacement. Next is variable manipulation element. So next, it actually changes the numerical value of signal, like we amplify the signal. So in this way, we call it as variable manipulating element. Okay. Next is signal conditioning element. So our data which we are obtaining from any sensor or transducer may be containing sort of noise or some other unwanted signal which are not in use. So we want to filter or we want to change the such other characteristics of that signal, that then we use signal conditioning block. In this block, many processes like linearity, integrating, differential, addition or subtraction procedures can be done. This can also be done like modulation, filtration, clipping or clamping. All these procedures we can adopt in this stage. Then once we get the refined data, then it needs to be transmitted. So transmission can be either done by wires or wireless. For example, like in our satellite, we are using wireless transmission, or some landline phone where wire transmission is done. So it depends upon application where what kind of transmission is required. And lastly, data presentation element, that block which is used to actually display the data in some numerical form, or we can say some sort of deflection of some needle, like our LCD, LED, okay, so or plasma. All these screens are data presentation screens. Okay, so if we want to record the data in graphical form, then we use strip chart recorders. Okay, or like our voltmeter, ammeter. These gives the reading in deflection of needle. So this was about elements of our basic measurement system. So next is, what is sensor and transducer? How can we define our sensor? A sensor is nothing but a device that responds to changing phenomena, like human body. Human body is the best example of naturally existing sensor. Our skin respond very quickly to change in whatever change in occurring in our surrounding. If temperature rises, body start sweating in order to maintain the temperature. Okay, so sensor is basically that device that respond to changing phenomena. Okay, so and transducer is basically that device which convert one form of energy into another. And generally we are today we deal with all the signals in form of electrical. So we talk about electrical transducer. So this statement becomes a transducer is a device which convert one form of energy into electrical energy. So it becomes electrical transducer. Okay, so transducer or sensor transducer may be mechanical as well as electrical. So mechanical transducers are those primary sensing elements that respond to change in the physical state of system and give output in different form, like I discussed bellows, Bourdon tube, spring. Okay, so basically mechanical transducer convert the one form of mechanical energy into another form of mechanical energy, like these are used to convert pressure into displacement. So they become primary transducer. Okay, and next is electrical transducer, which convert the output of mechanical transducer or any other physical quantity into electrical energy, like thermocouple, RTD, LVDT, optical encoders, all these are electrical transducers. How can we classify these transducers or sensors? First of all, we can classify by active and passive. Next is there may be analog and digital transducer. Next is primary and secondary transducer. What actually electrical transduction principle is being used to convert physical quantity into electrical quantity. On this basis, we can have resistive, capacitive and inductive transducer, and next is transducer or inverse transducer. Let us talk about all these transducer one by one. So first is primary and secondary transducers. These transducers, primary transducers, are directly senses the input signal and convert that physical property into electrical signal is termed as primary transducer. So basically these transducers directly convert physical quantity into electrical without any intermediate stage, like our thermistor, RTD, thermocouple, all these are primary transducer. But secondary transducers are not like that. They require some sort of intermediate stage. They first convert signal into another form, and then that output of first transducer is converted into electrical output by second stage transducer, and which is termed as secondary transducer. Or we can say in this we require two transducer. One is used to convert one form of energy into another, then that another form of energy is converted into electrical one. Let us consider this example. Like here, this is Bourdon tube, which is our first transducer, and this is structure of LVDT. Okay, LVDT works upon the displacement of this core. So this is responsible for sensing the displacement only, but we are going to measure pressure using this LVDT. For this, we make an arrangement. We connect this core with free end of this Bourdon tube. This is C-shaped Bourdon tube. What happens when pressure rises? This Bourdon tube tries to get stretched in this manner. When it will get stretched, okay, this core will get displayed to this side, and core displacement will be converted into electrical output. So here output is proportional to displacement of core, and that core displacement is proportional to the pressure. Okay. So here we have used two stage transduction. So this becomes our primary transducer and this becomes secondary transducer. Next is analog transducers and digital transducer. Analog transducers are those transducers basically which gives output which is continuous in nature or which is function of, we can say, time. Okay, so LVDT, thermocouple, all these examples of analog transducer. On the other hand, digital transducer gives output in discrete form, or we can say in the form of pulses, like our optical encoder. Okay, so it becomes digital transducer. Next is active and passive transducer. Active transducers are basically those transducers which do not require any external power source for converting any physical quantity into electrical output. Okay, like photovoltaic cell, piezoelectric transducer or thermocouples, all these transducers generally do not require any external power supply to convert their physical input into electrical output. Okay, but on the other hand, passive transducers, they do require external power supply or auxiliary power supply for conversion. For example, inductive, capacitive, resistive, all these transducers are passive transducers. And next is inverse transducer. As we know, inverse transducers are those devices which convert any physical quantity into electrical quantity. Okay, but so inverse transducer is that which convert any electrical quantity into non-electrical quantity. For example, are piezoelectric crystal. Piezoelectric crystal behaves in either way. It behaves as a transducer as well as it can behave as inverse transducers. So when voltage is applied across its surface, it changes the dimension. Okay, like our thermocouple. Thermocouple is also an inverse transducer. What happens when we give electrical signal in its to that junction of this dissimilar metal? One junction automatically get hot and second becomes cold. Okay, this is known as Peltier effect. Next is, what are basic characteristics of transducer? So these characteristics can be classified as input, transfer and output characteristic. So what are input characteristics? Under this category we have what is type of input and the operating range and the loading effects on the transducer. Yes, type of input. So first characteristic under input characteristics is type of input. Obviously we should know for what type of input we are going to use our transducer. Like for if we are going to measure some temperature by using some transducer, so we should know that our input is temperature. We cannot use pressure transducer over there. Okay, so accordingly we have to select our transducer. So and then second is operating range. Okay, we should also have the knowledge of what is our range of that particular measurement. Accordingly we can select our transducer. Okay, and next is loading effects. So the transducer that is selected for any application should have no force or power energy, okay, from the quantity under measurement. Okay, it means that the quantity which is going to be measured should be used in measurement only. It should not be like that transducer circuit is drawing or extracting that energy just to drive itself, and there is no there is loss of that input quantity. Okay, so ideally we should have infinite input impedance. Okay, so that all the energy can be used for measurement only. Circuit becomes incapable of incapable of using that energy for itself only. Then second is transfer characteristics. So under this we have transfer function, error, and response of transducer to environmental influences. So what is transfer function? We often use this term in our mathematical subjects. Transfer function is basically that quantity which relates input with the output, and mathematically we define it as transfer function is equal to Laplace of output over Laplace of input, keeping all the initial conditions equal to 0. Okay. Next is sensitivity. As we know, what is sensitivity? Sensitivity is a minor change in input brings a major change in output. So sensitivity for a transducer for particular measurement should always be as high as possible. Okay, so this rate of change of output with respect to change in input should be high. And on the other, scaling factor is inverse of sensitivity, that is 1 upon SD. Okay, this will become 1 upon dq naught upon dqi. Next is error. Error in transducer, when we say that our output is not following the standard output, we say that error has been generated in the system. Okay, for example, if we are getting output as q naught dash, while it should have been q naught, so we say that error is equal to difference of these two quantities. Okay, so we can classify error as scale error, dynamic error, or error due to noise and drift. So scale error can further be classified as zero error. Okay, zero error is that error in which output deviates, okay, from its theoretical value by a constant factor, okay, over the entire range of a transducer. On the other hand, sensitivity error, where error changes by constant value, that, or we can say some sort of multiplying factor. And next, scale error can be classified as non-conformity error. This is that error where error is changing continuously at every point. And next, hysteresis error. As we know that output doesn't depend only on the input. It may depend upon the input quantity which were applied previously on the system. Like we draw hysteresis curve for steel, magnetization curve of steel, or we can say this is non-superimposition of loading and unloading curve. Okay. Next, what that response of transducer to environmental influences. This is our last characteristic. As we know, it should not be subjected to any disturbance like stray electromagnetic or electrostatic field, mechanical shocks, vibration, temperature. Our transducer should be least immune towards all these factors which may exist in its surrounding. Next is output characteristics of transducer. First is type of electrical output. What is our next output impedance? Then useful range. Type of electrical output, again, once we should know that what is our type of input, we should also know that what is possible output of that transducer. Okay, whether it is in form of voltage, current, or impedance, or time function of any amplitude. Like if this is our transducer and it gives output in form of voltage, but our next stage is responsive, और we can say जो मतलब यहाँ पर सिर्फ इसको करंट की रिक्वायरमेंट है. ओके, तो we cannot use this transducer which is giving output in form of voltage. We will be requiring those transducers which can give output as a function of current. And second is output impedance. Like input impedance, it should be ideally infinite. On the same way, the output impedance ideally should be 0, so that we can minimize loading effect as minimum as possible. 0 impedance, output impedance means that we can transfer maximum amount of power of energy to the subsequent stage of that particular instrumentation system. Next, useful range of any transducer, that the output range of transducer is limited at the lower end by noisy signal. We can means the lower value of range is decided by the noise signal in the output, and the upper limit is decided by the maximum useful input level. Okay, so these were the basic characteristics of any transducer. So on the basis of which we can say that these are the various factors which influence the choice of transducer, like operating, what is operating principle, like it may be resistive, capacitive, or inductive. Sensitivity, we require sensitivity high or low. Okay, operating range, what kind of operating range we do require. Accuracy, cross sensitivity. Okay, what is cross sensitivity? For example, we are measuring pressure. Okay, and the same we are measuring pressure by using Bourdon tube and LVDT. Now, Bourdon tube is an elastic element. Okay, which can change its shape due to temperature rise as well. We use this setup for pressure measurement, and we require that our setup should be responsible for pressure only. But Bourdon tube is changing its shape if temperature is rising, which is not our interest एट दिस मोमेंट, हमें टेम्परेचर नहीं मेजर करना है, ओके लेकिन टेम्परेचर की वजह से आपका बॉर्डन ट्यूब की तब भी डिस्प्लेसमेंट शो कर रही है, तो इट बिकम्स पार्ट ऑफ क्रॉस सेंसिटिविटी, ओके सो इट शुड नॉट हैपन. नेक्स्ट इज एरर. एरर शुड बी as minimum as possible. Transient and frequency response. Transient response means कि how system is responding with respect to time, what is its peak time, rise time, maximum, peak, overshoot. So a transducer should meet all these requirements of its transient behavior. If it is not satisfying these parameters, then we should not go for that particular transducer. Loading effects, that input impedance should be high and output impedance should be as low as possible. It should be friendly with changing conditions of our environment and should be insensitive to unwanted signals. So all these are basic characteristics, basic parameters which influence the choice of a transducer. Okay. So this was all about sensor and transducer. Okay. Jai Hind everyone. Thank you.